Okay, so this session is going to be about Docker. And obviously Docker is a little different than some of the tools we've taught so far because we can't run it on the hub. That's largely due to a security issue. Running Docker, I'll talk a little more about this later, but running Docker often involves having root permissions, which means that you're kind of like running as an administrator if you run Docker. And so we unfortunately can't run it on the hub, at least not easily. So what this means is that if you're here and you didn't see my message in the general chat about installing Docker, then I'm going to start out for the first maybe 10 minutes or so talking about Docker generally. And this is your time to install Docker if you haven't got it installed so far. And whoops, I need to share my screen, I think, for Zoom. Okay, so if you need to install Docker, if you haven't done it yet, you just need to go to docker.com and you should be able to download an installer here. And once you've downloaded that installer, you just run it. It should work pretty easily. This is not like a lot of, like Docker is a commercial piece of software, so it has a very advanced installer included. And the main thing to be aware of here is that if you're on a Mac, just make sure that you have the correct chip type. I know a lot of people think that there's always confusion about whether you have Intel or Apple chips. So if it doesn't work, if it gives you an error about your chips, just try the other one. But hopefully most of you have got this installed already, but now's your chance to install it if not. So most of this lesson I'm going to be doing in a terminal. This is my bash terminal. It may look different than yours. If you don't know how to get this terminal open on Mac, it's very easy. You can go up to the little magnifying glass in the upper right and just type in terminal and run that, and that'll give you a terminal just like the one I'm using. It won't look the same necessarily, but it will be the same terminal. The colors and stuff are just a configuration kind of thing. On Windows, I put some instructions in the general chat about installing either the Windows subsystem for Linux or Git Bash. I think Git Bash is the easier one to use generally if you're not sure, but typically if you follow the instructions I put in the general chat, I believe that in order to start Git Bash, you would go to the start menu and just search for Git Bash, and I think it'll let you start it that way. I haven't used Windows in a very long time, so if anyone is having trouble with Windows, let me know, or let me somehow. I can try to help, but or I'll do my best anyway. And if you're on Linux, I assume you know how to start a terminal. All right. Okay, so before we actually start doing anything with Docker, though, I'm going to just tell you a little bit about what Docker is. So Docker has been around for a while. It was designed to solve this problem involving containerization and virtual machines. It's used by it. In fact, I would say that its primary use case, the primary use case for Docker, is big corporations who have purchased AWS nodes or Google Azure nodes, or basically cloud nodes, and want to be able to quickly start up a kind of uniform software environment where they can run something. So one of the big innovations of the Amazon cloud when it was originally kind of came out about 15 years ago or so, was that there was this notion of elastic computing where you could grab some nodes when you needed them, and then you could give them up and not pay for them all year round. And some of the burden that comes along with grabbing a node and running it kind of when you need it is that, well, if that node has the right architecture and the right software installed, then you're fine. If it doesn't have the right software installed, then you need to install that software before you even start running that node. And if you started that node up because someone logged into your service and now needs a node to run, you don't want to take the time to install that software. The idea behind Docker is that it manages virtual machines and snapshots of virtual machines, where you can install a bunch of software yourself and have kind of a snapshot of that installed software as if it were sort of its own operating system. In a lot of ways, Docker is very similar to Git, and we're going to see some of that as we go through the commands and things. But instead of being about repositories of source code, it's about layers of software installed on the virtual machine. Docker actually got its name. The whole notion of containerization comes from the idea of shipping containers. And I'll admit up front, I know nothing about shipping containers except what I'm about to tell you. But my understanding is that in the shipping industry, there was a long period of time where shipping was very expensive, unnecessarily expensive, I should say, because there wasn't such a thing as a standardized shipping container. And so when people package stuff up, they had their own packaging and their own ways, and you maybe didn't use a whole shipping container, you maybe just needed a little bit, and then there was like half of an empty shipping container. There were a lot of these kinds of problems that came about because there wasn't a standard size. And when the shipping industry standardized shipping containers, it led to this enormous increase in efficiency as a result of having standard shipping container sizes. Docker is supposed to solve that same problem, except for software instead of physical shipping. And you might notice, so if you downloaded Docker and installed it, is anyone aware that they're running the Docker? It's called the Docker daemon or Docker desktop currently. Okay, so some of you are. So you can tell if you're running it because when you go up to your, so on a Mac, when you go up to your menu bar, there's a little icon here that's probably kind of hard to see, but it looks a little bit like a whale with a bunch of boxes on top of it. In Windows, I think that's like down in your lower right somewhere. I'm honestly not sure. But basically, the first thing we're going to want to do is start up this Docker background process, the Docker desktop. So on Mac, I've already got it running, but you can just once again click that the magnifying glass and just type in Docker, and then you can run that. I've already started it. It'll bring up a window and say it's starting up, and then it'll take a second. On Windows, you pretty much need to do the same thing, just in the start menu, search for Docker, and then run the Docker program. Is anyone actually using Linux? Okay, we'll just not talk about Linux then. Great. Oh, Tomas, are you using Linux?
Yes. Sorry. Yep.
You know how to start Docker?
I do usually use the icon though, but yes. Maybe.
Okay.
Yeah. Isn't it just Docker?
Well, there's a command Docker. So everyone should be able to type this right
Or
now.
Docker run or something.
If you type,
Yeah.
yeah, so if you type Docker version, that'll tell you if you have Docker installed. But this command will work even if you don't have the daemon running in the background. If you installed it on Linux, it probably is running automatically. You probably don't need to do anything. But if you get an error, let me know. I can try to help you through it. Okay, so once we've got Docker, so like I said, this Docker command line will work even if you don't have Docker running. Sorry if that's a little hard to see. I can make this a little bigger too. Yeah, the Docker command line will work even if you don't have Docker running, but a lot of the commands that we are going to use after this one will fail in some way if you don't have Docker running in the background. And that's because the way Docker works is it runs a process in the background that kind of manages everything all the time, and you use a command line just to communicate with it. Okay, so any questions so far? Okay, so I just want to talk real briefly about what my use case for Docker is most of the time. I basically have two use cases. One of them is I want to try out a piece of software that requires some really complicated library to install, or some library I'm not very familiar with installing. Or maybe it runs only on a certain, like it only runs in a certain Linux distribution or something like that. If they've produced a Docker for their software, I don't need to worry about any of that. I don't need to worry about installing software. I can just run it using a Docker. Or if I need a particular Linux distribution, like I have a Mac, but I need to run this on Ubuntu Linux, I can create a Docker container that is running Ubuntu Linux, and I can log into it and use it just like it's my computer, and I can install the software there and use it. So that's one primary use case I have for Docker. The other one, which is more relevant for science and publishing software and such, is that whenever I publish a paper that has any software involved, I always make sure to include a Docker image with it that has everything installed that anyone would need to run that software, so that if someone else comes along and wants to try to reproduce my results, they can just pull up the Docker image. They don't have to go find the version of NumPy that I had installed in 2010 when I wrote this software or whatever, they can just pull up the Docker image and have that version that I used and run it inside of the Docker that way. So we're going to see some very simple examples of this today. We'll see how much we get through. There's much like Git, Docker is a big, complicated piece of software that's designed to do a lot of things for a lot of people. And so there's a lot of nuance to the way it can be run. We're going to do a very simple use case here where we basically are going to build up a really simple little calculator inside of a Docker container. And when I say calculator, I mean it will add numbers. That's about all it will do. Okay, but before we get into that, we're going to start by doing a simple example. We're going to say Docker. We're going to pull, which means we're going to pull a Docker image down from what's called Docker Hub. Docker Hub is kind of like GitHub. You can post your Docker images there and pull them. We're going to pull hello world. Now this should go pretty quick. This is not a very big image, but basically we just pulled it. Now, if I type ls, there's no like hello world directory here or anything. It didn't check out a repository. It rather pulled the image, and Docker manages your images and containers in like a mystery file system that you never have to think about. So somewhere on your computer is this image, and we'll talk in a minute about how to see that. Okay, so we've pulled that. We can now say Docker run hello world. So this will just tell Docker, go ahead, you've pulled the image, now go ahead and just run whatever's in that Docker. And we get this message, hello from Docker. This message shows that your installation appears to be working correctly, et cetera, et cetera. So this is actually just an image that Docker has published to be a test image to make sure that your Docker is working. Is everyone's Docker working? Okay, great. Perfect. All right, so I mentioned that when you pull a container, Docker stores it somewhere on your computer. If you want to see a list of images, you can use the command docker image list. And you can see here that we have this repository called hello world. It's got a tag, which is sort of like a version number. Here it says latest, which is just the latest version. It's got an image ID. So every image in Docker has a unique identifier. It's just a string of hexadecimal. And we'll talk a little more about that later. It says a little bit of information about when it's created and how big it is. So this is that's how you can see the list of Docker images. You can also see a list of Docker containers. And I will describe what a container is and the difference in just a second. Now, when we type, and I believe you can type either Docker container list or Docker container ls, they're the same with Docker image. Okay, so there's this notion of an image and there's this notion of a container. What's the difference between the two? Well, an image is a snapshot of a virtual machine that you've built. It's not running, it's just ready to be run. It's sort of like all the data you need, all the libraries, how the file system's built, that kind of thing. A container is where you take an image and you actually start running it as a simulated virtual machine. So for the brief second that hello world container was running, if we had typed Docker container list during that brief second, we would have seen it in the list. But then Docker hello world finished and it exited, and so it stopped, and now we don't have the container there. Now that said, if we type Docker container list -- ol, you can see that there is a container ID here called hello world that was created 2 minutes ago and exited 2 minutes ago. So there is a record of that container having run here. And this container is now considered stopped rather than running. And with the reason that Docker persists this record of the container here is because a lot of times when people build containers, they don't intend them to just run and stop. They intend them to be like a SQL server, for example, that runs and you would start it up and it would run, and then maybe you need to shut down your service and you would shut down the server and then you would start it back up. And so a lot of times Docker images and Docker containers are meant to start and stop and start and stop and continue running at different times. So we're not going to talk too much about that. That's more of a use pattern that people use when they're trying to like use Docker to run a server like like if you were Twitter, or I guess Twitter doesn't exist anymore. If you were X, I guess, and we're trying to use Docker to manage login nodes or something like that, you would want to be able to start them and stop them at different times. Okay, questions so far? All right. Let's look at this. Okay, so typically, if I am starting to make a new Docker image, and before I do much here, I'm going to go ahead and move CD into my desktop. You can work wherever you want. This is not really important. I just want to keep this in kind of a clean spot. And I'm going to go ahead and make a directory called Docker and CD into Docker. And I'm just going to do my work in this directory. Now this again, Docker doesn't care too much. We'll talk about what it cares about the file system in a minute, but you can generally do any of this work anywhere in the file system. I just want it in a nice clean spot where I can delete it later. Okay, so typically if I am going to build a Docker image that I'm going to use to package up my scientific software, that's kind of the use case that I use most often, and that I'm going to use as an example kind of today. If I'm about to start that, typically what I would do is I would start with a Docker image that contains Ubuntu, which is a very basic Linux distribution. Now, we're not going to use Ubuntu today because Ubuntu is actually a pretty big Docker image. It's a few gigabytes, and I don't want us to wait through downloading a few gigabytes. So instead, we're going to use a different Linux distribution called Alpine. Alpine was designed specifically to be very small. We can go ahead, we could run Docker pull Alpine to pull Alpine, but we can also just Docker run Alpine. And if we haven't pulled it, Docker will pull it automatically for us. So let's go ahead and run this. So it first says I don't have this locally. I'm going to go ahead and pull it. And it pulls it here and says everything's fine, but then it doesn't seem to do anything. If I just run that again, I think it will do the same thing. It does nothing. So why might that be? Well, this is a image that just contains a Linux distribution. It doesn't have something to do when you run it. It's an operating system. So what you can what this distribution is made to work with is you can say Docker run Alpine, and then you can give Alpine some arguments. So let's say cat/etc/os-release. So in Linux, the cat command concatenates something to the screen. It just prints the contents of a file out. The /etc directory contains configuration stuff, and OS release typically contains just some text about what operating system you're running. And so if we run this command, we'll see that it prints out that we're running Alpine Linux. It's got a version ID, a place you can go to put bug reports, etc. So that seemed to work just fine. It's just that when we Docker run Alpine, if we don't give it a command, it doesn't do anything because it's not set up to. Okay, so what if we want to interact with the Alpine Linux? Well, we can say Docker run, and we can say Alpine, and then you might think we would say sh for shell or bash, depending on sh and bash are usually aliases. So we could say bash. However, this is not how we usually run this command, and the reason is because if we want to run bash, we want something interactive where we can type and it can print to us. And so we need to tell Docker we're going to run interactively. So I'm just going to go back and say Docker run -it, which stands for interactive. And then we can say Docker run interactively Alpine and run the bash command. I think that on this particular Linux distribution, you have to actually say sh, not bash. So Docker run -it for interactive, Alpine sh. That better work. Yeah, okay. So now we have a little prompt here. All this is telling us is that we're in the root directory of the whole file system / and then this # typically means that we're logged in as root on Linux. But if I type ls, I can see that this is what you would typically find in the root of a Linux system. And I realize that may be a little hard for people in the room to read with the colors, but this is basically bin, etc, lib, mount, proc, run, the typical directories you find in the root of a Linux distribution. We can interact with the Docker container here. We can run stuff that's installed here, but I'm just going to exit for now. And that brings us back out of the Docker container and back to our prompt. Okay, questions so far?
One question, sorry, I didn't understand. It runs in Linux because it's connecting with the Docker servers, or?
It's not. Let's see how to answer that. So when we first ran this Docker run Alpine command, it connected to the Docker servers and downloaded the image for Alpine Linux, which is a distribution of Linux. And then when we say Docker run -IT for interactive Alpine SH, it takes that image that it downloaded and it starts it up in the background of your computer. It starts it up as sort of a virtual machine running Unix in the background and lets us interact with it. Does that make sense?
Oh, thank you. Yes.
Yeah, okay. Okay. So there are lots of Docker images out there already. In fact, just about any piece of software that we use in this course will have some kind of, well, not all of them, but much of the software we use in this course will have some kind of Docker image already ready for you. So for example, if you wanted to run Python, you can actually just Docker pull Python :3.8, for example, if you wanted to run Python 3.8. And I believe that'll just go and find a Docker image with Python 3.8 installed and download it. And just real quick, while this is downloading, we may cancel this in a minute, but I just want to show you how you can find these. So here I'm at docker.com, but I believe that if we go to hub.docker.com, that will take us to Docker Hub. Docker Hub, like I said, is a little like GitHub. And you can search for Docker images here. It's a little bigger. So for example, if I wanted a Docker image that had Jupyter already installed in it, if I wanted to run Jupyter on my home computer, let me just search for Jupyter and see what we find. Okay, so there's like a Jupyter Hub, Jupyter base notebook, and chances are, so these aren't the ones that I've usually used. I've usually used this Jupyter Hub image. There's a whole bunch of these. Some of, like this one, for example, Jupyter SciPy notebook already has NumPy and SciPy and a bunch of the kind of common numerical utilities installed. So you can click into here and there's information on it. But basically, if you Docker run this notebook, or sorry, this Docker image, it will actually start up a whole Jupyter server inside of the Docker container on your computer, and then you can connect to it and work with Jupyter using that image. So this is a great use case for Docker in general. Jupyter is tricky to install on your own computer. It can absolutely be done, but this is a really easy way not to have to do that. We'll talk about how to you can tell the Docker image how to access your local hard drive so that you can work with your own files and things, and we'll do that in a little bit here too. Okay, so there's tons of these. There's a library I maintain called Neuropythy that is mostly about cortical surface. Oh wow, I didn't find it. It's mostly about it's a library for cortical surface analysis largely. I'm pretty sure that if we go to hub.docker.com/r/nben, which is my Docker username /neuropythy, I think it will find it. Yeah. So there's a Docker basically that I've installed Neuropythy in, so the people who want to use it can just start it up and run Neuropythy. Okay, so this is how you can find these Docker images. There's lots and lots of them out there. I said if you have a software need that you're having trouble installing, I suggest looking on Docker Hub. Okay, yeah.
Okay, Docker images probably are not allowed to interact with each other, right?
They are actually, but it's limited, so you have to tell them how to. So in fact, one of the ways that Docker is often used is that you'll have a whole Docker image for your database, like a PostgreSQL database. And you start that one up and you tell it that it can talk on a certain port to the Docker image that's running your like web server. And then and what's nice about that is they're completely isolated from each other. So if you accidentally screw up the installation for your web server, your database is still just fine, and they can't interfere. Yeah. So that's actually a really common use case. That said, I don't find that it's very useful in like scientific publishing and stuff very often, but if you were trying to build a web server or something like that, it's a great use case. Any other questions? Okay. I meant to point this out, but so if we look at any particular Docker image, it has a name. In this case, the name is nben/neuropython, and then it has a tag. And I mentioned this is kind of like a version number. So you can see like here's tag 0.12.6, 0.12.4. These are different older versions of NeuroPython, older than the latest version. And when we refer to Docker images, we refer to them by their name and then colon and then the tag. Now, this one doesn't have a username at the front, like NeuroPython is nben/NeuroPython. That's because this is like an official Docker supported image, so it doesn't need a username. Okay. All right, so we've downloaded some images and we've downloaded some containers. If we now type Docker image ls, we'll see that we've got this Alpine, this Python, and this hello world container. And you'll notice that they each have a size over here. This one is about 1 gigabyte. This is only a few megabytes. This one's really small. These can be very large. Docker images in general can be very large and they can take a lot of space. And so it's oftentimes I have to go through and clean out my Docker images, and that's quite common. Similarly, if you start a container and then you stop it, or like you finish with it, there's still a record of that container sitting around and it can take up a lot of space. So there are a few commands, let's just talk about to clear these out. First of all, the simplest one is we can say Docker rm, and then we can give it, Docker image rm, and then we can give it one of the image IDs. So for example, I think we're done with this hello world. I'm just going to copy this and paste it here. So it gives us an error. It says, can't delete this because it's being used by a stopped container. So if we say Docker container list --all, we can see that there's quite a few stopped containers here. But there's one in particular that, and this is not screen wrapping all that well, but this one in particular used the hello world image. This is the image column. And since this is a stopped container that we might want to start back up again, we can't just delete the image. So instead we need to delete this container first. So let's say Docker container rm, and then we're going to take the container ID, which is also this kind of hexadecimal string, and delete that. Okay. Now if we say Docker container list --all, we won't see that hello world anymore. So if we now say Docker image rm and we give it this hello world ID, now it says it's untagged and deleted. And now if we say Docker image list, we shouldn't see it. Yeah. To be honest, I don't use these commands very often. What I usually do is unless I'm actively working on a Docker image at the moment, what I usually use is a command called docker system prune -a. This will just clear out everything pretty much. So if you run this, you'll have to re-download containers you want to use. I'm not going to actually push enter right now, although it won't break anything if you do. It will prompt you and say, basically, are you sure you want to clear out your whole Docker cache? A lot of times what happens to me is I just keep using Docker and letting images pile up until I'm out of disk space, and then I realize I've got 500 gigabytes of Docker images sitting around and I have to go clear them out. And this command will do that very effectively. You can also say, I believe you can say Docker container prune, and this will remove, it gives you this warning here, it will remove all the stopped containers. And a lot of times this is exactly what you want to do. You just want to get rid of those containers that are sitting around that are not being used anymore. So I'll just say yes. And there we reclaimed 8 bytes of space, apparently. So not very much in this case, but that can be useful for getting rid of unnecessary containers. Yeah.
All of my data lives in a virtual server
Mhm.
that is locked down by my university.
Mhm.
How would I use Docker with that data without pulling the data to my desktop, which is massive,
Mhm.
and also having a massive Docker container?
Yeah. So is this data that you can mount locally, like
But
you could? How do you usually access it?
I SSH into a server and then. we
And you
have-
run things on the server? Yeah, okay.
It's virtual.
Yeah, so if you're running on someone else's server, they're probably not, unless you like, you work with them closely or something, they're probably not going to give you access to Docker on their server, because when you run Docker, there are security issues when you run Docker, basically. So what they can give you is Singularity access, or which is now called Aptainer. So Singularity and now called Aptainer is very similar to Docker. But it's designed to be user local, so it doesn't have the same security issues as Docker does. It's a little less powerful, and there are some things that it can't do as well, but for the use case you're talking about, it's almost always exactly the right solution. And I don't have Singularity installed right now, so I can't give you examples, but there are very simple commands like single line bash commands that will take a Docker image you've built and turn it into a Singularity container you can run locally in Singularity or Aptainer. And in particular, the question about data is kind of important. Like oftentimes we're running a Docker container, but the Docker container doesn't have our data inside of it. Whoever built it for general use, not for our particular data problem. So maybe we'll talk about that right now, actually. So well, we'll talk about that in just a minute once we've written a very simple calculator or something. So there's a way to basically take a directory on your computer and put it inside of the Docker, like virtually inside of the Docker image, so that it can access it. And we'll do that in just a minute. Great question, though. Any other questions? Yeah.
So if you're doing that with the Singularity or Aptainer thing, and then you wanna publish your code and
Mhm.
give a Docker thing with it, you give the Singularity thing instead?
So I've not done that, so I'm not 100% sure of this answer, but I'm going to say what I think might be right. I believe that the typical workflow is that you build the Docker image, and then the individual user uses the Docker image to make us. Sorry? No. The individual user uses the Docker image to make a Singularity image for their user. So it's typically, and it's very like, the command is something like Singularity. I'm making this up, this isn't right, but it's like build image, and then you say Docker : and then /neuropython, and it just makes you a Singularity image out of that Docker. So it's very easy. Now that definitely wasn't the right command or anything like it, but it is similar to something that simple. It's not. I just don't know it off the top of my head.
Okay, so you go back to Docker as the like general.
That's how I've always done it. Yeah. Okay. So all right, so we're going to get to putting data inside of the Docker container in a minute. But first, we are going to do a couple more things. We're going to start by actually building up a Docker image that has some useful stuff in it. I say useful. We'll see how useful you think it is. But okay. So so I'm going to start by just saying Docker run -it alpine sh again, just to get us back to that shell. So now I've got a prompt here that tells me I'm inside of the Docker container. This particular distribution of Linux has a tool for installing things. So first of all, if we wanted to run Python in this container, Python's not found. Python not found. Python's not installed inside of this container. It's designed to be very small and simple. But if we wanted to install it, we could. So APK is sort of the apt package manager for this particular distribution of Linux. And we can basically say apk add -- updates python3 py3 pip and python3 dev. So these are just basic Python tools for Python 3. Okay, good. I haven't run this in a while. I wasn't 100% sure that was going to work. But it looks like it's working fine. So we can install this inside of the running container, and then we'll be able to use Python 3. And again, this isn't installing anything on your computer, it's all inside the container. Now we can run Python 3 and oh boy, it's probably going to make me. Okay, that works. Okay. Now that's great, but now if we get out of Python and we exit out of the container, we've kind of lost that installation. That container is still running. In theory, we could start it back up, but there's a better workflow to use here than just running this inside of the container and then having to do it again later. And for this, we typically make what's called a Docker file, which is just sort of like a very simple set of instructions for Docker on how to build a container. I'm going to go ahead and use Nano. I hope I have Nano installed. Yeah. I'm going to go ahead and use Nano. It's a very simple text editor to edit this Docker file. And Docker files always start with a capital D and then are lowercase for the rest. And it's just Docker file with a capital D. Okay, so Docker files have a format that it's basically a very simple kind of like almost like programming language for Docker. The first thing we usually say is from, and what from says is when we build this Docker that we're building in this file, we're going to start with some other Docker image. And so in our case, we're going to start with Alpine. Now, if you wanted to build if you wanted to take the Jupyter SciPy notebook and install your own library and have a Jupyter like a Docker image that contained Jupyter and your library, you would start with Jupyter SciPy notebook. But we're just going to start with Alpine for this example. Okay, so we start with Alpine. Another common command is the run command. And the run command just tells it to run a command, surprise, surprise, inside of the Docker container as it's building it. So in our case, we want to run that command that we use to install Python. So I'm going to say run apk add -- update Python 3 py3 -pip and Python 3 -dev. Okay. Once we've run this, it'll have installed pip. And so if we want to then run another command that says, for example, pip install Python, that will also work once we've run that first command. And then, so these are instructions for building up the kind of image we're going to use. But another kind of command we can put here is actually the command command. And what this tells Docker is when someone runs the Docker run command for our Docker, what should it do by default? So in Alpine, it doesn't do anything by default; it just exits. But in like, for example, if I wanted to take a command line utility that I'd written as part of a paper and I wanted it to be packaged up in a Docker so people could run it using Docker, we can tell it what command to run here. So I'm just going to say /bin/ well, let's say sh. I think that's what we ran last time. So we'll just say go ahead and start up the shell. Okay. I'm going to push Control O to save this out. And Docker file is a fine name. And then I'm going to push Control X to exit. Yeah, question.
So I just had a question with the Docker file.
Mhm.
Is this Docker file like unique to this Alpine image, or like would you put other commands on how other images run in this file?
So this is, yeah, so the Docker file is for building a single Docker image. So if you wanted to have two different Docker images that talk to each other, for example, then you would need two different Docker files in two different directories. Does that answer your question?
Yeah, I think so. So, if you had, like, how would you manage Docker files then? Like, if I have two Docker files, and just like, what is going to be and how I?
Yeah, that's a great question. And I think that as we build this, I can answer that a little bit more clearly. Yeah. So we've made a Docker file here. Obviously, this is just a file with text in it. But now we want to tell Docker to build this Docker file. So we're going to say Docker build. I'm going to say -t. And I'm going to, -t stands for tag. What tag do we want to give this Docker image that we're building? I'm gonna say Alpine test :latest. Now we can name this whatever we want, but if we want to push it up to Docker Hub, it needs to be prefixed with our username. That's typically how it works. And then we're going to put a dot at the end. That's the last part. So Docker build -t Alpine test :latest, and then dot. And the dot just says we're building the Docker that's in this directory using the Docker file in this directory. So this will produce a bunch of output, and that's fine. That means it's working. But now I want to just go back to that question. So we had to tell it we were building in the current directory. And when Docker builds an image, oh boy. Interesting. I think they've changed the way. Well. Okay, so this failed to build because we had an issue with running pip, it looks like. And I'm not sure I totally understand the issue, but that's okay because we didn't really need to run that pip install Python. It was just an example. So I'm just going to nano my Docker file to open it back up, and I'm just going to comment out this line. My guess is that if we wanted this to work, we would need to run something like Python 3-m pip or something like that. But regardless, we're just going to comment that line out. I'm going to push Control O to save it again, and then Control X to exit. And then I'm just going to reissue that build command: Docker build -t Alpine test :latest dot. And that actually will demonstrate something kind of interesting, which is that that second time I issued the command, it ran really fast. It didn't have to do all that stuff again. That's because Docker is actually very smart about remembering what you've done before. So as you're building a Docker image, it runs each line of that file one at a time. And every time it runs a line, it saves out what's called a layer of the Docker image. And if you then edit your Docker file and delete a line somewhere, it will say, oh, I can go back to the line before that one you deleted and start from there because I don't need to rerun all those steps above it again. So that's why this ran a lot faster. Okay, but I was saying that we always have to Docker build a certain directory. When you build a Docker image, it will use the Docker file in that directory. And as far as being able to interact with things in the file system and put them inside the Docker, which we'll see in just a minute, you can only access that directory during the build process. So Docker wants you to put different Docker files in different directories. And if you want to build them separately, you can, what oftentimes you'll find is you'll have a Git repository with a bunch of subdirectories, each of which has a Docker file in it for different Docker builds. Yeah.
Okay, so you're building like directories local on your computer, but the image is not local on your computer.
The image is stored locally, but can be uploaded, of course. Yeah, but yeah, all of the Docker commands we're going to be using, except for Docker pull and Docker push, operate on your own computer and don't interact with the like Docker Hub. If you Docker run something, or if you say from some Docker image, it will download those for you automatically. But none of this, unless we tell it to, none of this will push anything up to Docker Hub or interact with Docker Hub outside of those kinds of uses. So as far as like Docker organization, there's another tool called Docker Compose. If we have time, I don't know if we'll have time, we'll talk about it a little bit. It's also used to coordinate multiple Dockers. But honestly, Docker Compose and coordinating multiple Dockers is typically more of like a web service kind of use case. For scientific publishing, I've only really ever had to run one Docker at once for the most part. Okay, so let's go ahead and test this Docker image we made. We can say Docker run. I say -it for interactive, and I'll say Alpine -test :latest. And I don't need to put like sh as a command or anything at the end because we told that Docker file that the default command was sh. So if I just run that, it brings us right up here. Now, we would have gotten something similar with our previous Alpine command. So let's just make sure Python was installed. If I type Python 3, I get Python. So we now have a Docker image that has Python all installed for us based on that Docker file we produced. Okay, exit out of here. Then exit. I think I want to exit. Okay. Okay, so now I'm not going to actually submit these commands because I don't want to upload this Docker image to Docker Hub, but I'm going to show you how to do that in case it becomes something you need to do at some point. So let's suppose real quickly that this Docker image that we just made is some very valuable piece of scientific software and not just this Python installation. Yeah.
When I put the output test, I accidentally had a bracket in the middle instead of writing T. And then when I hit exit, now it's doesn't have anything in front of it. And it only like creates some lines.
Try pushing Control D.
And it just fades. Like the little thing.
Oh, it did. How about Control C? Okay. Okay, you got it. Okay, great. Okay, so let's suppose that we didn't just build an Alpine Linux with Python. We actually built some useful piece of software. Okay, so I want to upload this Alpine test we did to my Docker Hub account so other people can download it. The first thing I would need to do is rename the image so that it had my username at the front. So I could say, first of all, I'll say Docker image list. And I can find the image ID of this this Alpine test image, which I'm going to copy. And then I believe I say Docker tag. And then I think I say the image ID. I might have this command slightly wrong. We'll find out in a second. And then I would give my username and the name I want to give the Docker image. And I'm just going to use latest as the version. And now I think if I say Docker image list, there is an nben Alpine test latest. And if I want to upload this to my Docker account so that you all could download it and use it, the command is just docker push nben/alpine test latest. And in order for this to work, you have to have logged into your Docker account via the Docker desktop that you started up. There's a way to do that in the interface for Docker desktop. But this is basically how simple it is to push a finished Docker image up to Docker Hub. And once I had run this, any of you would be able to say Docker run nben/alpine test latest, and it would automatically download it for you and run it. Does that make sense? Any questions about that? Yeah.
Why would you use Docker over a virtual machine? If I can access a virtual Linux machine, why would it?
Yeah, so the question is why use Docker over a virtual machine? So you say virtual machine, but I don't know which kind of virtual machine you're using or what your virtual machine software is. So if you have a workflow working in your virtual machine and you then want to publish it so that I can use it, you need to train me in using that virtual machine, right? Or you need to tell me how to install it and how to get it working on my local computer. So it may not matter for you whether you're using Docker or that virtual machine. But it matters for me because I already know Docker because it's a very standard piece of software that handles virtual machines. So I think the main reason here is that Docker is sort of a standard in the space. That if you want to share your virtual machines and your virtual installations of software and stuff, Docker makes that very easy. And a lot of virtual machine software doesn't make that easy. That's the main reason I would give. Yeah. But if you have a working virtual machine that you like, there's nothing wrong with using that. That's any virtual machine system is a way to solve these problems of having to install software locally on your computer that works with the rest of your software. Docker also solves the communicating that or publishing it problem. Yeah.
And do things like supplying a free server license into a Docker image?
Yes, that's a great question. In fact, so you know FMI prep? Everyone heard of FMI prep? Okay. The best way to run FMI prep is by using the FMI prep Docker, because then you don't have to install all of the crap inside of FMI prep. And I say crap, but it's a lot of useful stuff, but it's all very complicated and hard to get installed and working together. So what you would, I believe you say Docker run, oh boy, I think it's Poldrack lab / fMRI prep. Latest, don't actually run this, it'll take forever to download. So we'll this gets back to the whole question earlier about how you like access files inside of Docker. But when you Docker run, there's an option -v, which stands for volume. The idea is you can take a volume being like some piece of your hard drive or some subdirectory and mount it inside of the Docker image so that Docker has access to that particular directory on your computer. And what you would do is you would say something like, and it's funny, let me just show you, I believe in my home directory, I have a FreeSurfer license file right here because I do this all the time. So you would say Docker run -v, and then I would say ~/fs license. And then I'd put a colon and I would say inside of the Docker image, I want this to be /FreeSurfer license.txt or something like that. And then when this runs, this file will actually be inside the Docker image as this file. And if the Docker writes to that file and changes it, it will change on my computer as well. Like it's actually accessing the same file. So again, I'm not going to run that, and we'll see another example of this in a minute. But that is totally possible, and that's kind of a design case. Yeah. Other questions before we go on? Okay, so let's actually make something a little bit more interesting instead of just this Docker with Python installed. So to start out with, I'm going to write a Python file sum.py. We're going to see if I can write this without any guide or anything. Basically, we're going to import sys. We're going to make list of numbers. We're going to say and args equals the length of sys.argv. So just in case anyone's not familiar, sys.argv is the command line arguments given to a Python instance when you run it. So the first argv0 is always the name of the program that's running, and then argv1 is the first argument, and argv2 is the second argument, etc. So what we're going to do is we're going to say for arg in sys.argv1 colon, and we're going to say that because we want to skip the first one, which is just the name of the Python program we're running. So this will basically iterate through the arguments that were provided. So if someone ran Python sum.py 1, 2, 3, this would iterate through 1, 2, and 3. So we're going to say num equals int of arg. And then we're going to say list of numbers dot append num. There's a much easier way to do this, but that's okay. Then we're going to say sum equals 0. We're going to say for num in list of numbers sum equals sum plus num. And then we're going to print at the end the sum is sum. And then we will run sys.exit to exit nicely out of the program. I'll leave that up for just a second. If you're clever, you can skip building up this list of numbers and just use the sum, but I wasn't clever, so this is what we have. I'm going to push Control-O to save this out. And then Control-X to exit. Is everyone done copying this, or do we need a second? All right, any other questions while we give everyone a second? Yeah.
How are you getting like in the border?
How am I getting tabs?
Yeah.
I think I just spaced. Yeah, I just put 3 spaces. You can put 3 or 4 spaces. I'm not sure. Oh, did your tabs look like that? Yeah, so I think it's because Nano's not very smart about Python code. Like Nano is a very simple text editor. It's not very good at this kind of stuff. So I would just use spaces. Okay. And then Control O to write that out, and then Control X to exit. Now I can just test this right here. I can say Python sum.py 1, 2, 3, sum is 6. Okay, so it seems like that works okay. All right, so we want to be able to use this sum.py inside of our Docker. So using the kind of example we just talked through with the -v, we can actually do that. So let's do Docker run -it for interactive. And then we'll say -v ./sum.py. So that's saying we're going to take this file, sum.py, on our computer, and this can be a directory or a file. If it's a directory, it puts the whole directory inside. And we're going to mount it to /sum.py inside of the Docker. So we're going to just put it right in the root of the Docker image. And then we're going to say we want to run alpine test :latest. So when I push enter, it's going to go ahead. Oh, I see. Sorry. Docker is very picky about how you provide what files you put inside of the image. And that's because of security issues. And it's complaining here that I put a dot right here. It doesn't like it when you put local directories, but you can access the files in the current directory just fine. I'm just going to get rid of that / and say mount sum.py, and I think then it'll work. Yeah. So if I now type ls, you can see there's a sum.py right here. Well, that's a surprise. I'm a little, okay, well, I'll just say I'm surprised that this mounted this as a directory. Let's try something slightly different. I'm just going to exit out of that. We're going to do docker run -it -v. I'm going to give $pwd, which is the full path of the current directory. So let me just show you really quick. If I echo $pwd, it's the current directory I'm in. So I'm going to say docker run -it -v pwd : /mount. So this will mount the whole current directory to the directory mount in the Docker, as kind of a way around the issue I was having a minute ago. Okay, and then we can say alpine test :latest. And now if we look in mount, we can see the Docker file in sum.py. Okay. I'm quite certain it's possible to mount individual files inside of Docker because I do it all the time, but I'm not sure what went wrong in the command line I did there. If I figure it out later, I'll post it in the Slack. Okay, so we can see sum.py here. If I cat it, of course, if I cat /mount /sum.py, we can see the code we ran, and we can then say Python 3 /mount /sum.py 1, 2, 3, and we get the sum of 6. So this is an example of taking a little bit of code and putting it inside the Docker. However, this is really clunky, and if I wanted this to work for someone else, if sum.py actually had something useful in it, I would need to distribute sum.py with the Docker image, and that's a real pain. So as you might imagine, there's ways that we can not have to do that, and we're going to look at that next. So I just went ahead and exited out of the Docker, and I'm going to go nano Docker file to edit the Docker file again. Okay, so I'm going to go ahead and get rid of this install Cython line because we really don't need it. And what we want is we want to install Python, of course, but then we want to put this sum.py file inside of the Docker, like permanently inside, not just mounted inside. And so we can use the copy command, and copy will let us access the directory that the Docker file is in any subdirectory. So I'm just going to say copy sum.py /sum.py, and basically this is saying take the sum.py in the current directory where we're building the Docker from and move it into /sum.py inside of the Docker image. And then if we want, we can come down to the command. And instead of having us run sh, we can say, let's, no, I might actually get this wrong. We'll see here. But we can say run Python 3 /sum.py. Now the command, the CMD command in the Docker image is a little bit weird. It doesn't actually want us to type the command like this, and part of that's because the command we're running could in theory have spaces in it or something. And so instead of providing it like this, you have to give it a list of strings like that. So just like it was a Python list or something, we put Python 3 and then /sum.py. Okay, so I'm going to go ahead and save that out with Control O. I'll leave this up for just a second. Okay, anyone need more time? It's okay if I. All right, I'm going to exit out, Control X. And now we need to rebuild this. So I'm going to say Docker build -t alpine test : latest. I'm going to call this alpine sum actually. Dot. Or we could say $pwd here. Same thing. Okay, that was pretty quick because once again, it didn't have to reinstall all the Python stuff. It just used the version that I was already installed in. We can see that it copied sum.py in. So now if we say Docker run alpine sum : latest 1, 2, 3. Uh-oh, something went wrong. It's saying exec1 didn't work. How about we run it without any arguments? The sum is 0. So something kind of worked, but it didn't totally work. When we tried to provide arguments, it didn't send them into the Docker correctly. So this is due to an unfortunate kind of complexity of how Docker runs things. I'm going to open up Dockerfile one more time. So this CMD command, you would think that you would use it to specify the command to run when you start the Docker, and you'd be partially right. If the user doesn't supply any input arguments, this is what gets run. However, what we really wanted to use here was what's called an entry point. And for our entry point, we want Python 3 sum/sum.py. The command then becomes basically, if the user doesn't provide any arguments after the Docker name, then it takes whatever's in the command and it adds it to the entry point as arguments. So for example, we could say that for our default arguments, we want 10, 20, 30. So I'm going to go ahead and push Control O to write that out. We'll leave this up for a second. Okay, I'm going to go ahead and Control X. Once again, we need to Docker build -t alpine sum latest dot. Okay, it built. And now if I Docker run, since this isn't actually interactive, I don't need the -it. I'm going to add a different argument that's just useful to know. If you say Docker run --rm, then it will automatically delete the container when you're done with it. So you don't have to go back and delete it later manually. So I'm going to say Docker run --rm alpine sum : latest. And now it says the sum is 60. That's because I didn't provide any optional arguments here. And so the command, which I put in 10, 20, 30 as the default values, those were used as the optional arguments. However, if I then say Docker run --rm alpine sum : latest 11, 12, 13. Oops, I misspelled my I said appline sum instead of alpine sum. Alpine sum latest, the sum is 36. So when I provide arguments, it ignores what's in that CMD list and runs it with these arguments. Otherwise, it runs it with the default arguments. Yeah.
Could you explain like what the command is?
Yeah, so let me just open up the Docker file. So the entry point is always the command that gets run when the Docker starts. If there isn't an entry point, then it will take whatever arguments you provide, and if you don't provide arguments, it will take whatever's in the command and treat those as the arguments. So let me just give you an example here. If we say Docker run alpine sum, let's suppose we didn't have an entry point. We commented this out. If I ran alpine sum python 3 /sum.py, this would run this command, but without arguments. And then I could add arguments, and this would all work. Now, this is if we don't have an entry point specified. If we have an entry point specified, then these two arguments will always get prepended to whatever you provide on the command line. Does that make sense?
Yeah, so earlier when it said this one was 0, it was basically because it was like depending Python 3 /py onto Python 3.
I think in that example that I used, that was before we had entry point, and so I didn't provide any arguments, so it was taking just Python 3 sum.py as the whole kind of command.
Mm.
Yeah. So let me back up a little bit. This might be a little easier. There's the arguments you give Docker when you say Docker run that come after the image name, and if you don't provide those, whatever's in command becomes the arguments. Those are the default arguments. Your entry point, if you don't specify it, then Docker will take whatever those arguments you provided were and try to run them as a command. If you do specify entry point, then it will run this command with these arguments, and it will append whatever command line arguments you get to that. Yeah, it's a little complicated. I don't know why they decided this should be called CMD and not args or something, but it is what it is. And it's a little bit confusing, but it works. Okay, other questions about that? Okay, sit here. Okay, so honestly, this is like 95% of all the Docker you need to know. You can use these Docker files to run commands that build things. You basically just run Linux commands in the Docker file. Debugging Docker files can be a little painful because a lot of times you have to try to build it and then see what fails and then try to fix it. And that can be a long kind of tedious process. A lot of times what people will do is suppose we're working on this Docker file, we're trying to build up a more complicated installation of software inside of our Docker file here. We could go ahead and start it up. And even if we have an entry point like Python 3 here, we can say Docker run, and then we can provide -- entry point to override the entry point. And we can say, I've installed half the software. I want to figure out how to get the rest to work. I'm going to start it up with the regular bash shell. And whoops. I think I need to tell it I'm doing it interactively. I'm just going to start it up interactively with the bash shell and say, okay, now I'm going to try apk oh boy, install. What was the command? -- add -- update, and I'm going to try installing some other software here at the command line. And if this command that I run works, I'll take it and I'll copy it into the Docker file. And so you can kind of go back and forth between running things in the Docker image itself and trying to build it from the Docker file until you get the Docker file to build properly. And then the idea is that you typically publish the Docker file in a GitHub repository, and then other people can download it and build it themselves, but they can also ideally pull your Docker image as you built it from Docker Hub as well. Yeah.
I feel like you almost just kind of answered my question. I was looking on Docker Hub, and I was like looking for examples of Docker files, and it seems like they're not like on here, so I would have to search for like the corresponding GitHub repo.
Yeah, so this is a good question, and let me just take a little bit of time to kind of talk about this. So We'll just use this NeuroPython library that I maintain as an example. So nben NeuroPython on Docker Hub is the Docker image of NeuroPython. And it doesn't like this, in theory, you can take one of these Docker images and get Docker to spit out a Docker file. I'm not sure if Docker will actually do that for you, but Docker Hub does not like track the Docker files. Instead, if you go to github.com/noahbenson/neuropython, you'll see that here in the root of this this repository is a Docker file. And this is the Docker file that I use to build NeuroPython. And it's a fairly complicated Docker file because at various times I was, there's like free surfer subjects that get pulled into this Docker file and stuff like that. But this is pretty much just the script that's used to build the NeuroPython Docker image. And so in theory, you can clone NeuroPython and build this yourself, and it should work. Now, of course, software gets out of date, so building an image is always a little bit fraught. If you're building an image using Python 2, you may find out that some of those libraries can't be downloaded from pip anymore or something like that. That's often a problem. So building a Docker image is not reproducible the way that running a Docker image is, but the idea is you build it and then you put it on Docker Hub and then people just use that image that's already pre-built. Yeah. Okay. I want to make sure and talk about one other thing before I open it up to general questions or other thoughts. So a lot of times, what you want to do is you want to publish a paper and you want to publish some code with it. And with Docker, you can put your code inside of a Docker image and have a command line. And you can tell the people who use this Docker image, okay, take your data directory, take your bids directory, for example, and put it in /bids inside of the Docker image. And since bids is a standard format, I know how to read it and I can look through it. And it'll be that makes it very easy for you to write some software that runs on their data. What you often want to do, though, is as part of the publication process, you want to be able to cite that Docker with a DOI, a document object index. So DOIs are like permanent references to papers typically, but ideally you want to be able to provide a DOI for a Docker image. And for that, you can use this command docker save. I'm going to say docker save -- help because I don't remember exactly how to use it. Right, okay. So basically we're going to say docker save -o for, and then we're going to give it a file name. So I'm going to say alpine sum.tar. And then I give it an image name, alpine sum : latest. What this command is going to do is take the entire image and turn it into a tarball file, which is just a way of storing like a Linux file system in one file. And we now have this alpine sum.tar file. And I could send this to you on email or something like that, and you can take it, and I believe you say docker load. Again, I need to look at the help because I don't use this very often. Yeah, docker load -I alpine sum.tar, and it will take that file and it will load it into a Docker image in my system. Now I've already got an alpine sum latest image, but it just overwrote that with the copy I wrote out. But the point is that you can take your Docker image and turn it into a file, and then you can go to a service like Zenodo, which will take files up to something like 50 gigabytes and save them permanently and give you a DOI so that you can publish that with your paper. So this is kind of a way to make sure that even 10, 20 years down the road, when the libraries we're using right now are no longer available, this file that contains a virtual machine that can run all of your software will still be available for people who want to download it and try to reproduce your results. Yeah.
Just to clarify on a technical perspective, there's no difference from pulling it from Docker Hub versus loading that.
Yeah, no difference. In fact, I'm pretty sure that when you pull from Docker Hub, on some level, you are just putting together a tar file that it then loads in. Yeah. Now it's probably more complicated actually now that I say that, because Docker is very clever about these layers of things that get added. So if, for example, I've pulled the NeuroPython Docker, which is based on the Jupyter SciPy notebook Docker, and you have another Docker that uses SciPy, we'll only have to pull the differences. But that's getting a little more complicated. This is just stuff Docker does to make it a little more efficient. fundamentally what you're saying is right. There's no real difference between loading from a file and loading from Docker. Yeah. Okay, other questions? Okay, so we have just a few minutes, so I'm just going to really quickly talk about this tool called Docker Compose. So if we go back to my NeuroPython library, and I realize this is probably a little hard to see. So there's not only a Docker file here, there's also a file called dockercompose.yaml. Docker Compose is basically just a convenience tool for running Dockers without some of the big kind of messy command lines we often have to use. So what I mean by that is when you typically, if you want to run fmri prep, for example, you're going to do something like docker run --rm because we don't want the fmri prep container to stick around once we're done. -it for interactive, and then we're going to say, okay, -v, wherever my data volume is, I'm gonna mount my subjects into the Docker as a subjects directory, and then I'm finally going to say coldrock lab /fmri MRI prep :latest, and then I'm going to go on and add the arguments for fmri prep, and these command lines get very unwieldy very fast. And we're just, even this is still a fairly simple version of a Docker command line. So what people often do is provide these Docker Compose files. So rather than build one, our Docker is pretty simple, so I'm not gonna go over that or try to build one for our particular example. Well, actually, we can do it. We'll go ahead and build one. We're going to say nano docker compose .yaml. Is everyone familiar with YAML or has heard of it? YAML is a little like JSON, but more human readable. That's a big oversimplification, but okay. So in a YAML file, we just need to set a few things. First of all, we need to tell it the version of the Docker Compose language we're using, and we're just going to say 3. And then we're going to say services. Services is just a list of things that need to be started when you tell Docker Compose to go. So I said Docker Compose is a sort of shortcut for a lot of the command lines and things in Docker. And so you often run it when you're ready to start something or run something. So we're going to say services. We're going to say alpine sum as the name of one of our services. And we're going to just say we want to build that in the current directory. Okay, I'm going to Control O to write this out, and then Control X to exit. And then we can say docker-compose run alpine sum 1, 2, 3, 4, give it our arguments. And it will first go ahead and build the local Docker image from the current directory using the Docker file, and then it runs it and we get the sums 10. So it did all that because we told it to run Docker Compose and use the run command, and we said alpine sum. Okay, let me just cap that Docker Compose again. Here we named a service alpine sum. So when we said run alpine sum, it went and found the service and said, okay, I want to run this alpine sum. First thing I need to do is get the image. Well, we told it that it needs to build the image from the current directory. You can also tell it to pull an image instead of building an image. And oftentimes the way that these Docker Compose files are used, again, is for more of the use case where you've got like a corporation trying to start up like a database and a web server or something. You would have a database server and a web server in your services, and they would both start up simultaneously and be able to talk to each other. I mostly use Docker Compose to simplify the command line so people don't have to write out a lot of the mess. But I mostly just wanted you to be aware of it. It's a kind of a little utility for simplifying some of the build process. We don't really have time to go into all the details of what you can do in Docker Compose. And honestly, most of them are not terribly useful for scientific computing uses. But you'll see it occasionally, and it's kind of a useful utility on occasion. Okay. Okay, I think I have one more thing to tell you about. And for that, I'm actually going to go back to the Jupyter Hub, neuroacademy.2i2c.cloud. Okay, so if you go into the curriculum, and you go to the Benson Docker directory here, this probably does not look anything like the other curriculums in the course. And this is not meant to be materials that you just look through like they are right here. In fact, they're not very useful in this setting. But if I come back over to my terminal and I'm just going to git clone git at github.com:neuroacademy 2024/curriculum. So I'm just going to clone the curriculum locally. I'm going to cd into that curriculum directory. And then I'm going to cd into Benson-Docker. If you look closely here, you might notice that there's a Docker compose file. And if I just cat Docker compose, there's a my Jekyll server service that is pulled from this particular Docker image. So what this directory actually contains is a website and instructions on how to run a web server. And the idea is you come to this directory and you say Docker compose up. It's now going to pull this Jekyll server. And then and by the way, Jekyll is it's a Ruby tool, I think. That GitHub uses to host the GitHub pages. So a lot of GitHub pages and wiki stuff is in Jekyll. But it's a nice little utility for writing a web page using like Markdown. And then having it run as a server. So you find it in GitHub related websites and stuff like that. You'll probably encounter it at some point. Okay, so this is now starting up, I think. There we go. So, okay, so once it finishes, it's basically going to start a web server running on my computer, and I'll be able to go to my browser and connect to it. It's just taking a little bit. And I'm going to just scroll up to make sure I see this right. Okay. So well, it seems that Jekyll needed to update itself before we start. Well, okay, it's starting. This whole lesson so the web server that it's starting up contains the Docker lesson we just kind of went through. And it's in sort of, if you're familiar with software carpentry, it's kind of in their format. You can also find this, I believe. Oh boy, I have it written down. Hold on. Well, all right, it's in my notes. I just am having trouble finding it. Okay, well, I'm gonna guess. I believe it's richford.github.io/Docker. Well, I'm gonna have to look this up the old-fashioned at github.com/Richford. So I taught this lesson a while ago with another data scientist here, Adam Ritchie Halford, and he has this whole set of pages running on his GitHub IO page. I just don't remember what it's called, and I'm afraid he might have taken it down. For introduction, okay. Okay, so I believe it's richford.github. Docker introduction. There we go. Okay. I will stick that in Slack so that you don't have to go through what I just did to find it. Anyway, this is the lesson we just went through. Just kind of laid out in text with most of the same examples. Okay, so this is finally got to the end where the server is running. So now we just basically have time where if I say localhost :4000, we get the same lesson. So this is right now running off of a web server that's running inside of a Docker image on my laptop. And that was kind of what I was trying to show you there. Although it took a couple hiccups to get there. Okay. Any questions on any of this? Yeah.
More of a conceptual question, what would be a typical workflow when you're, say, you're working on your project, so you're using fMRI prep to pre-process the data, presumably you're not building a container, but you're just referencing a specific version of this container. Then you're running a GLM in SPM that maybe, then you're going on the GLM data or whatever.
Yep.
Would you have separate containers for each of these steps, or would you build like a mega container that does it all?
Yeah, so that's a great question. In that I would say that for me, the answer would depend on how different the tools are I'm using. So if MATLAB's one of your tools, MATLAB can't really be Dockerized because it requires a paid license. So you can compile MATLAB code and put that inside of a Docker, and I have seen that work, but it is hard, or it requires some a lot of testing. A lot of times what I will do is when I start a project or when I start kind of the analysis phase of a project, I will go ahead, something like fMRI prep, I would run in its own Docker and just take the bids directory as output as the start point for the analysis. But once I'm at that point, I'll create a Docker based usually on like the Jupyter SciPy notebook Docker or something like that. And I will start it up and I will do my development inside of the Docker image. I unfortunately don't remember the command offhand, but there's a way you can take a container that you've stopped and turn it into a Docker image. So basically, if you develop the Docker as you go, you can write out a kind of snapshot of it and use that as your sort of a distributed Docker. So you can actually do a lot of development inside Docker as you go. Typically, once I get to the point where I'm ready to publish, I'll try to turn that into a Docker file though, because I want other people to be able to edit it and build it. That's the main advantage there. So once you're there, you hopefully have a pretty good idea of what you need to install and everything. And building Dockers and making a Docker file and debugging it can be a little bit of a pain, but I at least find that it's worth it. Someday we'll probably have a better solution to that, but that's kind of how I do it these days. Yeah. Other questions? Yeah.
How would be your routine between GitHub and Docker? So you're writing a script and you push it to GitHub and then, yeah, how would you do that?
Yeah, so a lot of the time I'll have the Docker file hold a Git repository into the Docker image, or the Docker file will be in the root of the GitHub repository, and I'll pull the GitHub repository, and then the first thing I do is Docker build to make it. So you kind of keep them kind of parallel. And if like this is a GitHub repository that contains your analysis code, you'll edit all your code, but you'll start up the Docker and you'll mount the current directory in like /code or something, or /repo. And then you'll do your development inside of the Docker while editing that code. Does that make sense? Yeah. So something like that is a pretty workable workflow. At the same time, if what you're doing is not super complicated, if you're using like basic software that's not terribly hard to get installed and everything, you often can just build the Docker file at the end and be okay. And that's, you know, if I can get away with that, I often do. Yeah. I saw someone on Zoom who had their hand up, but feel free to shout out if you have a question. Anyone else?
Hello, just wanted to ask, can you use Docker to collaboratively code with a buddy? So you avoid all the hassle of people having different OSs, and I find that even using Anaconda, it's not quite, easy.
That's a good question, and I would have to think pretty hard about that. I don't do a lot of I mean, when you say collaboratively coding, do you mean like,
Yeah, you're
where
working on
both-
a toolbox with a friend or whatever. Yeah, something like that.
okay.
Yeah.
Yeah, absolutely. I mean, you can use, for one thing, you can, if you're working on the Docker image, you can have like a Docker account you push that up to, and you can have them then download the Docker image, that kind of thing. I don't know that it's going to especially, like the advantage of Docker in a collaborative project is that you all have the same environment, and you can be sure that you're running the same code and the same versions of libraries, and that you won't, your collaborator won't get a different answer because they have an older version of NumPy installed or something. I don't know if it'll help you with like the collaborative workflow necessarily. It's just that it'll help you with those kinds of issues involving software and stuff. But I'd have to think about that a little more. That's a good question. Is there another question also in the back? Okay, well, I think it's afternoon, so I think we can stop here. Go ahead to head to lunch.